So we've looked at a bunch of different kinds of parallelograms. We went last time into a little bit of depth on rectangles. Now we're going to look at rhombi and squares. So rhombi or a rhombus. Rhombi is plural. They have opposite sides that are congruent, okay? They have opposite sides are parallel. So if you have one of these, sorry, that's a horrible picture. This one is the same as that one, and that one's the same as that one, okay? Opposite angles are still congruent. So this one is the same as this one, and that one's the same as that one, okay? Consecutive angles are supplementary, so these are still going to add to 180, okay? Diagonals bisect each other, so you still have that they're cut in half this way, okay? So this is the same as this, and this one's the same as this one, okay? So rhombi, however, have a couple more things. So all four sides are congruent because it's just a square without right angles. Okay, the diagonals are perpendicular, and I'll show you what that means with the examples below. So if you look at these, each of these inside angles are 90 degrees. So that's 90, that one's 90, that one's 90, that one's 90. In every rhombus, the inside angles here made by the diagonals are 90 degrees. Okay, and then lastly, the diagonals bisect opposite angles. So the diagonals bisect the opposite angles. And again, I'll show you what that means. So this is the same as this angle. This is the same as this angle. This one's the same as that one. This one's the same as that one. It cuts it in half. Okay, so let's look through this. So from J to K is 12. And then from J to N is 7. Okay, so just looking at this, we know that each of these sides are going to be the same. So if one of them's 12, they're all 12. This one's 7, the other half of that one's 7. But we don't necessarily have this one. Okay, but we do know that this is a right angle. If we have a right angle, we can solve for this side. Okay, so the only thing, if we use the Pythagorean Theorem, we have to make sure that the C is going to be the one across from the right angle, so it's going to be 12. So I'll go ahead and write that one in. Then we have 7 squared, and then I'll just go ahead and use a question mark. I'll use a question mark for the other one, just to make sure. Okay, so we can go ahead and solve this now. If we type 12 squared and we subtract 7 squared, we're going to get that whatever the one we're looking for squared is going to be 95. And then if we take the square root of both of those, we're going to get about 9.7. Okay, so we use the Pythagorean theorem there because that's a right angle in the center. So now we know that this one's going to be 9.7, and then again, the other one's going to be the same. Okay, so let's go ahead and look through. JM, from J to M is over here. It's one of the sides that are 12 because it's an actual side, not one of the diagonal pieces. From J to L is the entire diagonal here, so it's 7 plus 7 gives you 14. From M to N is the little half diagonal on this side, 9.7. Okay, and then now we're looking at from M to K, so the entire one. So it's going to be 2 times 9.7. Just going to give you about 19.4. Okay, so just label everything up and remember that the angles on the inside here, the angles on the inside there are always 90 degrees, so you can use Pythagorean Theorem. Okay, so number 2, from E to F is 23. Okay, and then from D to F, the whole thing here is 40. So I'm going to go ahead, instead of writing 40, I'm going to just go ahead and write that each of these are 20. Okay, remember this is a right angle to solve for this one. And go ahead and take a second in order to try these on your own. So again, this one's 20. There's a right angle here. You can solve for this one using the Pythagorean Theorem with this triangle. Okay, pause the video and try that one on your own. Okay, so going to the next one. From R to T is 22, so each of these halves is going to be 11. From U to S is 18, so each of these halves is going to be 9. Okay, Again, these are right angles, so you can go ahead and solve for this side using the Pythagorean Theorem. Okay, so let's just call it x for now. That's going to be the c because it's directly across a right angle. So we have a squared plus b squared equals c squared. So we have 9 squared plus 11 squared equals this x squared that we're looking for. So if we actually calculate the 9 squared plus 11 squared, you get about 202. And then if you take the square root, you are going to get that this missing side we're looking for is about 14.2. Okay, so this side that we're missing here, trying to erase that, okay, is 14.2, and that's going to be the same for all of the sides around. So go ahead and use that to fill in the blanks over there. And then let's go on to number 4. Okay, so the main thing to pay attention to these ones are that if they're in the same corner, they're the same angle. Okay, so those two are the same, these two are the same, and actually diagonal ones are the same. So this one, this one, this one, and this one are all the same. And then as long as they're on the same diagonal, they're the same. And these ones are the same. Okay, so if that one's 38, the one that's written there, this one, angle 3 is 38. Angle 4 and angle 5 are 38. Okay. We know that these two angles together are going to be supplementary because they're in a straight line like that. So we know this 180 minus 38 is going to give us this entire angle. Okay, so the 180 minus 38 is going to give us 52 degrees. Okay, so that's going to be all of the teal angles here. So I'll switch it back to the teal so we can see what's kind of going on a little better. So each of these are going to be, 52 is 2 of the teal, so 52 is the entire angle. If we, wait a sec. Yeah, okay, that's what I did wrong. So 180 minus 38 is not 52, it is 104. Okay, but we need to split it in between these two angles, so each of these are going to be 52 degrees. Sorry guys, I was looking at my answer key so I didn't have to get my calculator out or try and do it in my head. I messed it up. So 1, 2, 7, and 6 so are all 52 degrees. So 6 and 7. And then if we need angle number 8, we can see that this creates a triangle here. So we have to take 180 minus this 38 and minus this 52 in order to get angle 8. Okay, and that is going to give us 90 degrees. Actually, we didn't have to do it that way, because if we remember up here, it said that each of the diagonals are perpendicular, so the inside diagonals here are always 90 degrees. Okay, so again with this one, I'm going to draw out the thing so I can use one for sides and one for angles, just because it makes it so much easier. Okay, so zy, I'll do the sides over here, is 34. So that means all of these sides are going to be 34. Wy, so the whole thing here is 38, which means half of it would be 19. So this one's, from W to Y, so that's the wrong one. From WY here is 38, so each of these are going to be 19. Okay, and then if we want to solve for this one, which we do, we have to do the Pythagorean Theorem because we see that that one is the one we're looking for. This is a right angle, so this one across from it's C. So we have, sorry about that, I keep doing that. A squared plus B squared equals C squared. Okay, so 19 and X are going to be these ones. And then the C is 34 because it's across a right angle. Okay, so if we go ahead and solve for X squared, so we do the 34 squared minus 19 squared, we're going to get 795, which if we take the square root of both of them, we're going to get that X is about 28.2. So now that we've solved for that, we can go ahead and say that each of these little halves here are 28.2. Okay, so go ahead and use that to fill in the sides here. And then let's look at the angles. So it tells us, let's go ahead and make sure we label the vertices so we can see where everything is. W, X, Y, Z, and then these in the center. Okay, so it tells us that measure of angle Z, X, Y. So this one right here is 34. Okay, so this one's going to be 34. This one's 34. And this one's 34. Sorry, it's a little messy here. I'm going to erase this so I can kind of see what's going on a little better. Okay, so let's try and draw it. I got a little mixed up with the letters and everything. W, X, Y, Z, and this one's V. Okay, so Z, X, Y is this one is 34. Okay, this one's still going to be 34. This one's 34. That's what I'm messing up. So this one is not 34. If you go across, it's the same. So these two are 34. So across from it's 34. Okay? You know that each of these are 90. So if we need to find this angle here, we do 180 minus 90 minus 34, which is going to give us 56 degrees. So each of these are going to be 56 degrees. Okay. And now you remember each of these are 90 in the inside. Those are really horrible corners. So go ahead and use that to fill in the blanks over here. And we'll go on to the second page. Okay. So now we're looking at squares. Way easier. Way, way, way easier. So we know that a square has all of these properties we've looked at. So opposite sides are congruent, opposite sides are parallel. So basically, you have 4 of the same side, 4 of the right angles, okay? All of these are the same. All of these are the same. All of these are the same. Okay? Like that. Okay, so ABCD is a square here, and AD from A to D here is 11. Okay? So each of these sides are going to be 11. And then, in order to find the inside ones, we're going to look at this as a right triangle here because we know that the corners are all 90 degrees in order to be a square. Okay, so we need this side. So we have 11 squared plus 11 squared equals C squared because we're looking for the one across from the right angle. Okay, so we're going to get 242 equals C squared. And if we take the square root of both sides, that is going to give us that C, sorry, I wrote an X, is going to be 15.6. So, now that we figured out, we know that each of these, the whole thing is 15.6. If we divide that by 2 to get each of the little half diagonals, that's going to give us, well, I don't think it asks for the half diagonals, so I'll go ahead and just mark that this whole thing is 15.6. It's the same thing with this side, with the diagonal, okay? So now, we need BC, so BC from B to C is 11 because it's one of the sides. AC from A to C is this 15.6. It's one of the diagonals. From B to D is the other diagonal, so it's also going to be 15.6. And then from E to C is half of that diagonal. So if we do divide it by 2, it's going to give us about 7.8. Okay. I'm going to erase this so we can do the angles now. I would suggest coming over here and drawing another one, since you don't want to erase any of your notes, okay? So now, well, we don't really need to. DAB, okay, if we look at this, DAB, it's the corner, it's a square, so it's always going to be 90 degrees. AEB, AEB, 90 degrees. Okay, CBD is going to give us C to B to D, so that's half of the 90 degree angle, so it's going to be 45 degrees. And now if we look at BAC, it's also going to be half of the right angle, so it's going to be 45 degrees. Okay. So now I want you to try number 7 on your own. Okay, try it on your own. It tells you that TR is 17, so each of these little half diagonals are 17. Remember, this is a right angle, so you can use the Pythagorean Theorem to solve for this side. Okay, try it on your own. Okay, now we're going to look at some algebra. Remember, these two are equal to each other because it's a rhombus. Okay, so we have 9x minus 77 is equal to 3x plus 7. Okay, I'm going to subtract the 3x to the other side. 6x minus 77 equals 7. Add the 77. Gives us 6x equals 84. Okay, divide by 6. It's going to give us that x is equal to 14. But it asks us to find the side MP, which is going to be the same as any of the other two sides. So we have 3 times x is 14 plus 7, which is going to give us 49. Okay, so those two are equal. The sides are equal. This one, these two are equal. Okay, so go ahead again. Blank equals blank. Fill in those blanks. Get down till you solve for x. And then try and find angle FED with that. Okay, so it's going to be 180 minus whatever you get when you double one of these angles. So you fill in the x there, whatever you get. And that's going to be your answer. Type that in the calculator once you figure out your x value. Just plug it in right there. Okay. Next one, we're looking at a square. So it's a square. SW here is 2x plus 13. And then WU is this 8x minus 41. You can see that both of these are going to be the diagonals here. So they're going to be equal to each other. They're both half of the diagonal, sorry. And then once you solve for down for x, you're going to take that because it's looking for VT. VT is an entire diagonal, so it's going to be double one of these half diagonals. So 2 times whatever plus 13. And you're going to double it. Now we're going to lastly look at number 11. So this is going to be half of 90 degrees because it's one of those. So we have 7x plus 3 equals 45 degrees because it's half of that corner. Go ahead and solve for x on your own. You can do this on your own. So again, squares have it all. Rhombi have you have the inside right angles. You have the opposite sides still. You have the bisected diagonals. Okay, and you have these angles on the inside here are the same. They're cut in half. Okay, so again, let me know if you guys have any questions. I know I messed up a couple little things here and there. Let me know if you have any questions about anything I said. My mind got mixed up a lot, but that's okay. There's just a lot to look at. Let me know if you're getting mixed up too, and you guys have a great day.